as I told you before, in partial fractions there are like four methods of four ways of computing. But before going into those four types, there is a preliminary thing that we should check. That is, when we have two polynomials divided by each other, in order to calculate partial fractions, before going into those four methods, I didn't explain what these methods are, and I will do it in the later videos. But what I want to stress here is, before going into these four categories, there is a preliminary thing that we should check. And what is that requirement? That is, we need to check whether this fraction is an improper fraction. And what do we mean by an improper fraction? That is, we have to check whether the degree of the numerator is greater than the degree of the denominator. For example, if we have something like this, then the degree of the numerator is greater than the degree of the denominator. And what I mean by the degree is the highest power of the polynomial in numerator as well as in the denominator, right? I mean, degree is something that goes with the polynomial. The degree of the polynomial is equal to the highest power of that particular polynomial, right? Okay, so if the degree is higher than the denominator, higher than the degree of the denominator, we call this fraction as a improper fraction. Okay, so now this is the requirement that we need to check before going into these four methods, right? Reason is, if it is improper, then we need to do an additional calculation, and that is, we should do the long division for these two fractions. How do we do the long division? Now, since this is an improper fraction, I am going to do the long division for this given polynomials. So this is how we do the long division. Now this is x cubed, so this is x, and so to form an x cubed term we need x squared, and these two will be x cubed, and this one along with a negative will give you x squared, because like this times x squared will give you x cubed, and this negative one with x squared will give you negative x squared, and you have to subtract the two, so you will have x squared plus x, and to form an x squared term you will need plus x, because plus x times x will be x squared, and this one will give you negative x, and when you subtract that one, then it will be this is 0, and here it will be 2x and you don't have anything to take from the first row, so in order to form a 2x term we need a plus 2 in the top, so plus 2 with this x will form 2x, it should be 2x, and this with plus 2 will give you negative 2, and when you subtract these two things we will have plus 2. So what we can do is we can write this fraction as we started with x cubed plus x divided by x minus 1, and we can write it as x squared plus x plus 2 plus 2 over x minus 1, right? Now, so this is some sort of a algebra knowledge. If we have this long division, then we can write it in this format. So now what, like as a summary, what we did was we were trying to find the partial fractions for this unit, right? And I said there are 4 methods to compute, like 4 categories to compute partial fractions. But before thinking about these 4 categories, we need to find whether it is an improper fraction. And in this case, since the degree of the numerator is greater than the degree of the denominator, this was an improper fraction. So if it is improper, what we have to do is first we should do the long division and write it in this format, right? And the good news is, in this particular example, this might not be always true, but in this particular example, it is already separated into partial fractions. So this long division was the only thing that is required to do the to find the partial fractions for this particular example, right? So this one and this one will be the partial fractions for this particular example, but that doesn't guarantee you that just by computing the long division, it will not guarantee you that it will give the partial fractions. Now, for example, if we consider this one, this example, see here it is also an improper fraction because the degree in the numerator is 4, degree in the denominator is 3, so it is an improper fraction. So by computing the by doing the long division, we can rewrite this expression like this one, right? But this is not the correct partial fractions for the given expression. The reason is we can simplify this portion a little further by the methods I mentioned before, right? So this one falls under one out of these 4 categories, so we can do the appropriate calculation to simplify this term a little further. I'll explain it later, but what I want to highlight here is that doing the long division may not be enough to compute partial fractions, but sometimes in cases like this, it was the only requirement to find, like it was the only required thing to do for the partial, to find the partial fractions. In order to find the partial fractions, we only did the long division, right? And you might have a question, why, like now I said this expression we can simplify it a little further, so this is not the partial fraction, but then I said this is the partial fraction. So what is the difference between these two things? So to answer that question, I will have to explain all the details of these 4 steps. So bear with me for a moment and you will get a better understanding when you are when you learn all these 4 methods. So for the time being, just keep in mind that before going for these 4 methods, first we should do the long division if it is a improper fraction, right? Okay, and from the next video onwards we will discuss about those 4 methods.